morning everyone. Today I am going to give a video lecture on ASCII adjustment programs involving arithmetic instruction. Okay, this is the program. Here you are using 4 ASCII adjustment instructions. AAA ASCII adjustment after addition, then AAD ASCII adjustment before division, AAM ASCII adjustment after multiplication, ASCII adjustment after subtraction. I will discuss one by one. So we will discuss AAA instruction, ASCII adjustment after addition. The function of this instruction: on adding two ASCII codes, if lower nibble of AL register content is greater than 9 or auxiliary carry flag is 1, add 6 to it and clear the upper nibble of AL register and increment H by 0.1H. On adding two ASCII codes, if lower nibble of AL register content is less than or equal to 9 or auxiliary carry flag is 0, no alteration in AL content. Next we will go for AAS instruction, ASCII adjustment after subtraction. On subtracting two ASCII codes, if lower nibble of AL register content is greater than 9 or auxiliary carry flag is 1, subtract 6 from it, clear upper nibble of AL register, decrement H by 0.1H. The other possibilities: on subtracting two ASCII codes, if lower nibble of AL register content is less than or equal to 9 or auxiliary carry flag is 0, no alteration in AL content. The third instruction is ASCII adjustment after multiplication. Here we will multiply to unpacked BCD number, then result will be divided by 0H, quotient is stored in AH register and the remainder is stored in AL register. It gives an unpacked BCD number. The last instruction is AAD, ASCII adjustment before division. And here we will consider dividend as an unpacked BCD number which is stored in AX register, and it will be converted to hexadecimal number by AH register is multiplied with 10 or 0A in hexadecimal, and which will be added with the AL content. Then division is performed with the divisor is stored in some other register or memory location. I will discuss the program. Here the code segment, written in the program in the code segment. Start with the code segment, assume CS column code, and consider to ASCII number 31 and 39H. 31 is stored in AX register which is added with 39H. That use ASCII adjustment after addition instruction, and it will perform following function that is explained in the previous slide, and convert it to ASCII form, add 3030 to AX register. We will discuss ASCII adjustment before division instruction. Here we will consider divisor in BL register and the dividend in AX register which is in unpacked form. The AAD instruction, it will convert this unpacked BCD into hexadecimal number. Then we will divide by a divisor that is stored in BL register. Then we will discuss third instruction, AAM. For that I taken two numbers which should be in unpacked form, unpacked BCD form. Move AL, 05 and move CL, 05. Then I multiplied, and here the result will be stored in unpacked form, and it will be stored in AX register, and which is converted by adding 3030H to the suitable ASCII code. We will go for ASCII adjustment subtraction instruction. You have taken two numbers 34 and 38H, and then you use the ASCII adjustment after subtraction instruction. It will convert to will be converted, then it will be converted to ASCII code by adding 3030H. So we'll execute this program. The procedure for execution is go to File, save the program, and go to File, Exit. Then you have to use the following commands to execute the program: masm program name .asm followed by a semicolon, and click on enter. The next command you have to use a link program name .obj followed by a semicolon, click on enter. The third command you are using your afdebug. To execute the program, we'll use the afdebug command. Afdebug program name .exe, and click on enter. You will get a debugging window. We'll execute the program step by step. For that, you have to click F1. Okay, and the AX register, you have the content 31, which is added with the 39H. So the result will be result in AX content, it is as 6A, and then you'll use the ASCII adjustment instruction, and it will be converted to stable form. So you'll get 0100, and then you use the instruction add AX 3030, and 3030 will be added to AX register. So you'll get the result as 3130. Then the BL register will save 09, and the AX register will load the unpacked BCD number. Then we'll use the AAD instruction, which will convert your unpacked BCD to hexadecimal number. So you'll get 48 there in AX register. Then you'll perform division operation. So you'll get the answer as 0008. Next, the AL content will copy 05, and the CL content is also 05. Both are in unpacked form. And use the multiplication instruction. You'll get a hexadecimal number. Then you'll use the ASCII adjustment after multiplication instruction. You'll convert the number to unpacked form 0 to 05. Then add 3030, and you'll get 3235 in AX register. Then perform subtraction operation. For that, you take the two numbers as 34 and 38, which is stored in AX register. 34 is stored in AX register, which is subtracted to 38, and you'll use the instruction AAS. So you'll get the answer as FE06. Then add 3030 to convert it to a stable ASCII code. You'll get the answer as 2E36. Then we'll pass 4C as to AH register and use the interrupt to terminate the program in 21. Thank you.